So you said today is the 25th, I think. So 1 over x?
1 over x plus 1 over x plus 2 equals 1 over 4.
Very good. So this is a what type of equation?
Rational.
Very good, the rational equation. We have to state two restrictions immediately. And they are?
0.
Yes? Perfect. If you use my method, which I recommend, but I'm fine if you use a different method, any method you want. I have to find the LCD. It's the next step. What is the next, what is the LCD for this problem?
4x times equality x plus 2.
All different factors we see. X is not factorable, x plus 2 is not factorable, 4 is factorable, but it's only numbers, so I have 4x, x plus 2. Now I have to think about the adjustments at the top for each. So I have to find, if I don't have answers, if somehow I can't find an answer, even if it's 1, for any of these, or more than 1, the least common denominator is incorrect.
But how did you get 4x plus 2?
1 factor, 2 factors, 3 factors. All of them have to be there.
Okay.
If we have 10 factors, all of them have to be in the least common denominator. If we have 2, then we have 2. We have 3 factors. I can't disregard any of them. Good. So then x was multiplied by what to get this?
4 equality x plus 2.
Very good. 4x plus 8. 4x plus 8. X plus 2 was multiplied by what to get this?
4x.
Very good. And last but not least, 4 was multiplied by what to get this?
X squared plus 2.
X squared plus 2x. Do we agree with all steps? Any questions on any of the steps? Any questions? Okay then. So now the numerator will be this times 1, which is 4x plus 8, plus 1 times this, minus 1 minus 2x, minus x squared minus 2x. So the numerator becomes negative x squared. This is 8 minus 2, which is positive 6x. And this is plus 8 and over 4x, x plus 2. And now this is my reminder. Now you got to the stage in which you change this into a proportion. I had 3 fractions all over the place. I now changed it into a proportion. So at this point, we're ready to cross multiply. This times 1 is negative x squared plus 6x plus 8 must equal 0. Is this okay so far?
Yes. Thank you.
Okay. This is now a quadratic equation. I will always refuse to solve a quadratic equation with a negative leading coefficient. You can do whatever you want. I will never, ever accept to do that. So now I realize that this is negative 8. So I need a negative and a positive, and I will never be able to get negative 6. So I will not waste my time and immediately go to the quadratic formula. Negative b plus or minus b squared minus 4ac. But since negative 4 is here and negative 8, I'm going to change it into positive over 2 times a. Just because I don't want to put too many parentheses and mess them up. It's up to you. You can put them in. It's no problem. So finally, we have x equals 6 plus or minus. 36 plus 32 is 68. So 68 is divisible by 2. And then I have 34 divisible by 2, and I have 17. So this will be the square root of 4 multiplied by 17 divided by 2. Because my math lab will ask us to simplify fully. So I change it into 2 times 17 because I can take the square root from 4. So therefore, I have x equals 6 plus or minus 2, the square root of 17 over 4. Of course, I meant 2, but I wrote 4. You know what I mean. So it will be a terrible mistake to simplify in a sum. But what you can do is separate. 6 over 2 is 3. 2 over 2 I can simplify plus or minus the square root of 17. My first thought is this. Well, it's clear that this equation has two solutions that are irrational numbers, not rational numbers. 3 plus the square root of 17 and 3 minus the square root of 17.
And I have a question. Why would it not be negative 2? Because it's like the a is a negative x, so why would it be 2 times negative?
That's why I multiply both sides by -1, so I don't have to deal with a negative in the denominator.
Okay.
But you have to get the same answer. So if you use this, then you will have 6 plus or minus the square root of 36 minus 4ac, so you will get the same thing, right?
Yeah.
Minus from the formula times -1 times 4 times 8. So you still get under the square root, you still get this.
Yeah.
Right.
Okay. I just did the negative just to go away from 2.
But because you will have negative here and you will have negative here,
Yeah.
it's the same thing. Right?
Right.
Because you have to write negative. Now, because you're using this, you have negative here. Because you're using this, you have negative here.
Yeah.
So when you separate, -6 over -2 will still be 3.
Yeah.
And plus or minus over -2 will be negative plus or minus. I mean, negative plus. It's the same thing. However, you complicate things every time. You do not simplify the equation from the get-go. I don't recommend it. So always remember the steps for solving any equation. Again, I'm not saying that my method is the best or the only one. I'm just saying that, number 1, I identify the equation. Number 2, I state restrictions if that's the case. Number 3, I solve it. Number 3, I always simplify it, always. Because I don't want to have a negative here or a negative here and mess up and then ask myself what happened. So always simplify, always clean it up, and then solve using the method that is the best applicable method. Here, I was not going to complete the square. I was not going to take square roots. So my only chance was factoring, which didn't work. So I was down to quadratic formula. Better? Any questions on this? My pleasure, anytime. Any questions about anything else? Yes, please.
Can we go over, so we're supposed to do the 7 problems on the factoring sheet. Can
Yes.
we do number 7 together?
Yes, of course. Okay, I'm going to discard this. Okay, I don't want to waste your time. Can you dictate it to me? I don't want to start digging my stuff. I'm lazy.
4 times the quantity 2x minus 3 cubed times 2 times the quantity 5x minus 1 squared minus the quantity 2x minus 3 to the 4th times 2 times the quantity 2 minus 1 times 5.
It was
It's 5x minus 1.
Yeah, 5. 2 times the quantity 5x minus 1 and then times 5. All over the quantity 5x minus 1 to the 4th.
okay. So let's double check, make sure I copied it correctly. 4, 2x minus 3 cubed, 2, 5x minus 1 squared. So far, so good? Minus 2x minus 3 to the 4th, 2, 5x minus 1 to the 1st power times 5. The denominator 5x minus 1 to the 4th.
Yes.
Good, perfect. Again, like I kindly ask you to try to get into this habit, always simplify. I don't want to have a factor of 4 up there in front and a factor of 2 here, a factor of 2 and a factor of 5 at the end. Numbers are always presented in front. So I'm going to simplify the first term and say this is 8, 2x minus 3 cubed, 5x minus 1 squared, minus 10, 2x minus 3 to the 4th, and 5x minus 1. Again, this is just a suggestion. I think it's easier to see what we have and what we don't if we do that first. And also, by writing it again, I get more familiar. I familiarize myself with it a little bit. So now I'm looking at the top and I see how many terms? 2. Here's the first term. Here's the second term. First, second. Obviously, both have something in common, right? So first I will start with a number. 8 and 10. Do they have anything in common? The greatest common factor?
2.
2 indeed. So 2. Now I see that there is a 2x minus 3 in common, but I have to decide the power. And I always pick which power, the highest or the smallest? Of course, which is? Good. Then I also see the 5x minus 1 is common. And I see power 2 and I see power 1. Which power do I pick? Good. At this point, I can open a bracket, copy 5x minus 1 in the denominator to the fourth power. No matter what happens here, I'm allowed to simplify if I want to. I shouldn't rush, but I just want to make a point. At this point, I am allowed to do this. I remove a factor of 5x minus 1 from the top and a 5x1 factor from the denominator. Because this became a factor now. This is not a factor here. It's not a factor here, but now it's a factor. Because we factor out the common factor. Now I'm looking at this, and by comparison I say, okay, 2 is out, but there is something left inside, which is 4. Then I have 2x minus 3 cubed and 2x minus 3 cubed, they're out. Then from 5x minus 1 squared, I remove the 5x minus 1. So there is a 5x minus 1 left inside. Are you with me? Any questions?
I got how we.
Yes?
I got how we got before the brackets, but now I'm just confusing what we're putting in the brackets.
Okay.
Like I understood everything up to that.
Whatever I factor out, I have to show you, I have to convince you that if I need to put it back in, I get this term.
Right.
If when I multiply this by this, I don't get this term, this makes no sense.
Right.
Okay. 2 times 4 is 8. 2x minus 3 to the third. 5x minus 1 times 5x minus 1 is 5x minus 1 squared. As long as what I have in front times what I put in parentheses makes up the first term, I'm fine. Okay. At this point, I reach this stage. I have to copy the negative sign. So minus. Is this better? Now, again here, from this 10, I took out a 2. So obviously a good. From this 2x minus 3 to the fourth, I took 3 out. Yes. So I have a 5, and I have a 2x minus 3 inside. And then 5x minus 1 is completely out. Now I'm checking if I recover that second term. Let's do this together. 2 times 5 is 10. 2x minus 3 to the third times 2x minus 3 to the third is 2x minus 3 to the fourth. 5x minus 1 times 1 is 5x minus 1. Is that clear? Yes? Better? Okay. So now I will distribute. Combine like terms and get one factor out of this. This will be only one factor. It has 2 terms right now. So I already simplified this. I copy 2. I copy 2x minus 3 to the third. Inside I have 20x minus 4 minus 10x plus 15. Close the parenthesis. I no longer need a bracket. 5x minus 1 to the third. So 4 times 5x. 4 times negative 1. Negative 5 times this. Negative 5 times this. So 20x minus 10x is 10x and plus 11. And no one can further simplify this in any way, shape, or form. This is it. Anything else? Is this better?
Thank you.
My pleasure, anytime. Okay. Is there anything else you would like to go back to? Yes, please.
Those on my math log
Yes.
was x squared
Yes.
plus 7x minus 12 equals 0. And you're supposed to simplify the negative squared.
Very good. Perfect. The method of completing the square requires that we have the binomial or the trinomial, doesn't matter, whatever polynomial we have here, is in descending order. so that we can identify the middle coefficient. The middle coefficient in this case is 7. In step 2, we take that coefficient and we divide it by 2. In step 3, we have to square this number. When I square a fraction, I have to square the top and I have to square the denominator. And this fourth step is add 49 over 4 to both sides. At the same time, I will be moving 12 to the other side. I don't need it on the left-hand side. So then x squared plus 7x plus 49 over 4 equals 12 plus 49 over 4. Extremely important to remember that we must add to both sides. Is this okay so far? Any questions so far? Okay, perfect. So next, I have to change this into something squared and then find the least common denominator on the right-hand side. So when I square this binomial, I will get these 3 terms. Now you understand how important it is what we did on the first day of classes. So which binomial squared will give us this? X plus 7 divided by 2. Because x squared plus 2 times the first times the second will be 7x, plus the second term squared will be that. Finally, the least common denominator is, sometimes when I write so close to the bottom edge of the paper, it doesn't show, so I'm going to write it again when I scan the papers. So the least common denominator is the least common denominator. 4. There is only one denominator. It's 4 and 1, so it's 4. Good. So then I need to multiply this by 4 and this one, if you want, by 1. So 48 plus 49. So then x plus 7/2 squared equals, I think this is 97. Correct me if I'm wrong. Okay, after all this effort, and I have no idea how my math lab will verify that. I guess they could verify by asking you what to add to both sides. So they can. Okay, I completed the square, but I haven't solved the equation. So what do I need to do now? Yes. As I mentioned before, this method is useful, but for something else, actually. So then x plus 7/2 equals
The square root of.
yes. If I forget plus or minus, I get in trouble because I will not solve and I will not find the correct solutions. Remember, this is a quadratic equation, so maybe this is a good idea. I never thought of writing this for a quadratic equation. Every time you solve a quadratic equation, just say 2 solutions. This is my note to myself not to forget that I need to come up with 2 solutions. If I omit this, I only have 1 solution. Good, very good. Other questions for me? Yes, yes.
So, 2 times the first times the second, so is that where you got 7 over 2? Because it's over 2, so that's where you
Yes,
got
so the
2
first term squared plus 2
times the first
7/2 is 7 times x is 7x. Plus the second term squared.
So we have 7 over 2 because of the previous stuff. We actually already know what this square you get to 491. Just like
Anything else, or we go back to 2.1? I know, and I apologize that the last time I lost track of time and I held you over 2 or 3 minutes. I'll finish 2 or 3 minutes, up to you. You decide today. As a token of respect, you were so peaceful and kind, and you didn't scream at me. And you had a good reason to. Okay, so we'll finish, what, 2 minutes, 3 minutes late, early? What do you want? What did I do last time? I don't remember.
I think it was 5 minutes. I think it was 5 minutes. I'm not just saying that because I have to work at 4. And I was kind of
Okay, let's negotiate to 4 minutes.
we were on rapid functions going over Function and a relation.
Yes. So we were looking at where at the very beginning in which we identified.
Vertical line test.
Yes. So that's all we did in chapter 2. But I'm sorry. Do you have other questions for me? Anything else? Okay, perfect. So so we're looking at these bubbles, and we said x a function requires that to each input there is only one output. We can have a situation in which two different inputs go to the same output. That's okay, no problem there. But if we have the same input going to two different outputs, that's possible, but not a function. It's a relation. However, in all these situations, the domain is determined the same way, the range is determined the same way. Then we looked at graphs, and we said, I can tell for sure that this is a function because by the vertical line test, for this x value, I read only one y value. For this x value, I read only one y value, and the same thing here. Except the first one, which is a circle. So when I cut the circle with the vertical line at 1, let's say, I read y equals 2 and y equals 4. Therefore, it's this situation. For x equals 4, I get 0 and I get -6. So that is not a function. Okay, so we are still in section 2.1. Let's see what we can accomplish today. And I would like to copy a graph. And I'm copying it. It's very simple to copy. It will take a second. I'm copying 82 on page 231. So here's the graph. We will read from my graph or from the book. It doesn't matter to me. Okay, it starts. Okay. Just making sure that I'm, yeah. We're given this graph, and you're too nice. Sorry. Sorry. Okay. Okay, so I copied a graph from problem 82, page 231, and we have a bunch of questions here that we have to answer. So as you see, this graph goes from this point to this point, does not extend to the right or to the left. First question, does this graph represent a function? By the, so I will write 1, function, by the vertical line test. Function by the vertical line test. Number 2, we're asked to find the domain. And number 3, we're asked to find the range. Okay, so let's see how we determine the domain. I see that the leftmost point of this graph is -6, 4. However, it's an open point. It does not look like this one, which means the graph over there does not exist. But the leftmost point is at -6, but it really does not exist. And then it goes all the way for any x value till this point where x is 0, and it does not go beyond 0. It does not go beyond -6. So on the x-axis, I read the possible x values, and that will be the domain. So what are the possible x values for this function? From -6, to 0. Now we have to identify what symbols we put on the left-hand side and on the right-hand side. On the left-hand side at -6, what symbol should I write?
I think you put that in the wrong section. It should be domain, not range.
Oh, yes, of course. Thank you. Oh, I was just dreaming. With no reason. Of course I did. My apologies. Okay, so Symbols, left and right. Yes, parenthesis because this point is open. And here, a bracket because the point exists. In the same way, we will identify the range, but this time on the y-axis, from the smallest y value where the function exists till the largest y value. So what will the range be? -3, 2, and we have to decide upon symbols. At -3 and at 4, that's it. Perfect. Okay, number 4. Find the x-intercepts if they exist. Find the x-intercepts if they exist. Or x-intercept, I should put s in parentheses. The x-intercept or okay. I look at the graph, and by the x-intercept I mean the point where the graph crosses the x-axis. Please remember this is also important, very important, especially in this class. The x-intercepts are also called the zeros of the function. Terminology is very important, like a foreign language. So x-intercepts, when we talk about x-intercepts, we also mean zeros of the function. Same thing. So let's go back and say, does this function cross the x-axis?
Yes.
Yes. This is the point where it crosses the x-axis. Let's identify it as an ordered pair. Very good. The next question is number 5. What do you think I'm going to ask then? Of course, if it exists. Find the y-intercept. Okay, if it exists. Can a function have more than one y-intercept? Yes. A function.
No.
Can a function have more than one y-intercept? So that's why there is no discussion here. But there is only one, if there is. Okay, I'm looking back at the graph and I identify whether there is, if it touches or if it crosses. It's the same thing. 0, -3. Here's the point. Perfect. 0, -3. Here's my next question. Question number 6. Find f of 1. Before we look at the graph, let's identify what is the question asking us and what is it giving us. What do we have and what we don't have?
What is y when x is 1?
Perfect. So x is given. So remember, by comparison, this is the notation for a function. Function notation. It doesn't have to be f. It can be p of t. It can be v of p. It can be a cost of price or the number of units. It can be cost of price and so on and so forth. The cost of raw material based on the price of the raw material and so on and so forth. But this is the most widely used notation, f of x. So if I'm asked to find f of 1, I am told x is 1. Find y. Oops. Find the corresponding y. So I go back to the graph. I know how to graph x equals 1. This is not a point. This is a vertical line. So I draw a vertical line at x equals 1. Or I should say the vertical line called entitled x equals 1. I see.
That's -1.
I meant -1. I meant -1. At 1 is not defined. Okay. Yes. So let's write, this is awesome. F of 1 undefined. F of 1 undefined. 1 is not in the domain. 1 is not in the domain of the function. Thank you. All this time I was thinking of f of -1. Thank you very much. Can't get away with anything in this class. I don't even want to. Thank you. You're awesome, guys. Okay, so it crosses the graph of the function in a point. Of course, I'm not going to be able to read an exact number, but it doesn't matter. Let's read from my graph. If this is -2 and this is -3, let's say that this is -2.5. So which point am I reading from? I'm reading from the point -1, -2.5, which is, this is very important to write that f of -1 equals awesome. This is the point I'm making here, and let's write a note, very important note. Let's say I have this function. We will look at this function in the next chapter. It's a polynomial function degree 3. It could be degree 5, but any odd degree. So let's say I say that this is a point P, and the coordinate system is here, and I would like to ask you, let me see the time here. I would like to ask you, if this is x, how much is this? Extremely important to understand this. Correct. However, I need the other notation. Y or y is the same with?
Yeah.
Say it again.
Yeah.
Yes, indeed. Indeed. So the coordinates of P, if P is a point on a graph and the x coordinate is x, the y coordinate must be f of x. It's exactly what we just said here. Now let's look at Q. I'm just going to create a point Q and say this is 10. What will be the y coordinate? For sure, always f of 10. Please remember this is extremely important. Any point on the graph of a function has two coordinates, x and the corresponding f of x. If this is 10, this is f of 10. If this is 15, this is f of 15. Always. Extremely important concept. Okay, so I want to go back to one more question for the same graph, question 7. Find x such that f of x is -2. Now it's given us the y, so this is a y value, and we're asked to find x. Now what do I graph? Or at least imagine I graph. What do I have to graph? Or at least imagine I graph. I will be graphing a horizontal line where? Exactly. I will draw a horizontal line at -2. This is the line y equals -2. It crosses the graph in one point, and I will be reading the corresponding x value. According to my graph will be, that's it. So you will say that x equals -2, and then I will ask you what is the ordered pair you read from? -2, -2, and I will also ask you, not to annoy you, but just to make sure we all are on the same page, how much is f of -2? Indeed, -2. Okay, any questions on this? Yes, of course. One other thing that we want to discuss here is I would like to show you another graph. And finally, I would like to, after we look at the one more graph, I would like to talk about evaluating functions. And then we can move on to 2.2. Any questions for me here? Any questions for me here? Okay. So here's a graph, and I would like us to identify, so this is my page 5. I would like us to identify domain and range. Here it is. And here's one more. Okay, the first graph, is this a function?
Yes.
By the vertical line test is a function. Can anyone give us the domain of this function? Remember, from the leftmost point where the function exists, yes, 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 no, yes, 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 yes. Now let's give this a number. Very good, awesome. So indeed, negative infinity to negative 2, I picked negative 2, union negative 2 to infinity. This is indeed the a vertical asymptote, and indeed the function is not defined at negative 2. So the same idea with the range. From the lowest y value where the function exists, yes, 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 no, yes, 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 yes.
Negative infinity 0.
Yes. And union 0 to infinity. Perfect. Last one. Is this a function? It only has 3 points. 1, 2, 3.
Yeah.
Yes, by the vertical line test through the domain, this is a function. Perfect. Now let's identify the domain and range. As long as it's so, but see, if I draw a vertical line here, it doesn't hit the function. If I draw a vertical line here, it does not hit the function. So the domain is,
All the numbers.
as long as I can cross it with a vertical line. If I draw a vertical line and it doesn't hit the function is not defined there. Remember my mistake a second ago? I said find f of 1. I can draw a vertical line x equals 1. How much is f of 1? Right. So what can we say about this? What is its domain? But there are 3 points. And we know it's a function.
Isn't it, what was it? It was like all real numbers besides, but it's,
No.
going down that path, it's like the opposite.
Negative 1, no, because at 0 is not defined, at 2 is not defined, at 1.3 is not defined, at 2.5 is not defined, 1, negative 1.
It's just all the points in the graph.
Exactly, so let's just dictate them, and I'll put them in.
So it's -1, -2. Wait, for what we're doing the first one.
Negative
Oh, we're
1,
doing X, or
0.
there is nothing at 0.
1.
Yes, 1 indeed, comma, that's it. We cannot use braces, we cannot use brackets or parentheses, because this is a finite number of numbers or x values. This function exists or is defined only when x is -1, 1 or 3. The rest of the real line does not exist. So if I ask you find f of -1, you will say, yes, I can give you a y value. But if I ask you find f of 2.1, you will say, sorry, it's not defined. What about the range? -1, we start from the lowest y value till the largest y value. -2, comma, 1, comma, 2. Same thing, the range consists of exactly 3 values, and they are -2, 1, and 2 in ascending order. Very good. Let's see how we evaluate functions. Any questions? Any questions? Let's see how we evaluate. This is another very important concept. Let's suppose you give me this function, 2x plus 1 over x minus 3. and you ask me, what do you see? If you want me to tell you what I see, I'm going to tell you this. This is what I see. This is what I see. I see the pattern. It says, the function says this to me. F of whatever you want, whatever it is, has to follow the following pattern. 2 times whatever plus 1 over whatever minus 3. Once I understand this, whatever you ask me to evaluate it for, so for example, you say evaluate it for A, I'll say no problem. 2A plus 1 over A minus 3. If you ask me evaluate it for 0, I'll say no problem. 0 plus 1 over 0 minus 3 is negative 1/3. If you say evaluate it for 3, what will you say?
3 plus 1, 3 minus 3.
Good, exactly. And then what does that mean for this particular one?
Undefined.
Very good. Why is it undefined?
You got a 0.
Exactly. Remember, we discussed this before in rational equations, in which we said x minus 3 could never be 0, which obviously means x could never be 3. What is important now is to understand how to determine, for this function or any function, something like this. And I'll explain why in a minute. Once you understand the pattern, you should have no difficulties. But let's say, please tell me what I should write if I am asked to determine f of x plus h.
Determine what x is and then add h. Whatever.
So just to dictate and I'll do it. I'll write it.
2 times the quantity.
Very good. Awesome.
Plus h plus 1.
Very good. Over.
X plus h minus 3.
Exactly. I just did exactly what I did with all these. But this time, my whatever is x plus h. So this is my whatever, and this is my whatever. Whatever, whatever, whatever. I can't do much. I can simplify in any way, shape, or form, but I can just remove parentheses. 2x plus 2h plus 1 over x plus h minus 3. Very important to understand how to evaluate a function. And you'll see what happens in the next section, which is section 2.2. In section 2.2, we will look at 3 properties of functions. Okay? Would you like to evaluate one more function, or can we move on to 2.2? Okay, very good. So 2.2. More with functions. We're going to look at 3 properties in this section. Here is one property. Number 1, max min. Okay, let me list them. Number 2, increasing, decreasing, or constant. Increasing, decreasing, constant. Number 3, symmetry. Okay. Let's start with increasing, decreasing. So I'm going to start with increasing, decreasing, constant. That's the title. Increasing, decreasing, constant. So let's look at a graph. I'm going to go back to the same type of graph we just looked at a minute ago. Something like, let's say, it starts here. I hope you agree that there is a point here where the function turns, right? And there is a point here where again it turns. I'm going to put some numbers, let's say 10 and 15. Let's say this point is at 5, and let's say that this point is at 20. I just made it up for our discussion. It's not important. Is it okay, would you agree, if with the following statement? Let's say between these two numbers, between x equals 5 and x equals 10, if I say that the function is increasing, will you agree? I'm not telling you from which y value, I don't care. And I don't care to which y value is increasing. I'm only saying for x values between 5 and 10, the trend is increasing. Between 10 and 15, what is the trend? And between 15 and 20, what is the trend? Okay. What if I continue with the function, I continue the function like this? Let's say this is 30. What will you say it happens between 20 and 30? Constant. And again, I will say it increases. So these intervals are very important. But remember one thing, there are intervals for x in which we observe the trend. We notice the trend going up or down or constant. Not from which value to which value. So here's how I would write my answer for this function. F is increasing on only open parentheses or parentheses 5 to 10, union 15 to 20, union 30 to infinity. So let's check this out one more time. So between 5 and 10 is increasing, yes. Between 15 and 20 is increasing, yes. Union. Between 30 and infinity is increasing. Would you accept the answer?
Yes.
Okay. Now, can anyone tell us where is this function constant and where is this function decreasing? So f decreasing and f constant.
Decreasing from 10 to 15.
Yes. So between x values of 10 and 15, the function is decreasing. Very good. On the interval 10, 15. And it's constant on?
20 to 30.
Yes, 20 to 30. So this is one property of functions. They increase, decrease, and they could be constant. Okay. Here's another property of the max-min. I'm going to go back to the same graph. Okay. When a function is increasing and then at some point it starts decreasing, what do you think this will be called? Yes, it's called relative, sometimes called local, same thing. We use those two words interchangeably, relative or local max. But I have to be able to show that there is an open interval where all the function values are smaller than this one here, than this one. This one will be what? A local or relative minimum. But again, I have to show the open interval, that the function exists left and right, and furthermore, all function values are bigger. What about this one? Do you think that this point is a relative min? No, because the function does not exist on this side. So this is not a relative min. So the relative or local requires that the function exists on both sides of the point, and all function values in this case are smaller than this one, and in this case, all function values are bigger than this one, that we call the local minimum. Okay? So relative max, relative min.
So 20 would be maximum.
Here, in some books, this will be considered, it's a little bit weird, I have to admit. In some books, this will be considered a local minimum, a local maximum, because the function exists on both sides and the equal symbol is okay. So if I have equal to this, it's okay. In some books, they will say no, because it has to be strictly smaller than this value, the y value. Okay? So that's the max min, and we're going to look at the problem in a minute. So let's look at the last property, and then we will work with all these properties